Let's explore what a stateless component in React is. Here, we have a functional component named welcome message. Notice how it's simply a function returning JSX. It's called stateless because it doesn't manage or track any internal state. This component takes no props and always renders the same UI, a welcoming message. It's a perfect example of a simple, reusable component that can be used across your React application. Statelessness makes it predictable and easy to understand. Now, let's write a simple stateless component called userinfo. This functional component takes props, name and age, and renders them within a div. By destructuring the props directly in the function parameters, we keep our component clean and readable. This example shows how a stateless component can accept data from outside and display it without managing or changing that data itself. It's a great way to present static content that might change externally, but remains constant as far as the component itself is concerned. Did you know that stateful components manage their own state? Here, we have a functional component named counter that uses the useState hook from React. The useState hook allows us to add state to our functional component. In this example, we initialize the count state to 0. The counter component displays the current count and includes a button to increment the count. Notice how setCount is used to update the count state, causing the component to re-render with the new count value. Handling side effects is crucial in stateful components. This example demonstrates how to use the useEffect hook in React for fetching data. The fetchData component initializes its state with an empty array. The useEffect hook is then used to fetch data from an API. Notice how we update our state with the fetched data using setData. The empty array as the second argument to useEffect ensures the data fetching logic runs only once after the component mounts, similar to component didMount in class components. In this example, we're using the useEffect hook to fetch user data based on a given user ID. Initially, we set the username state to loading, to provide immediate feedback. Then, useEffect fetches the user's data when the component mounts or when user ID changes, thanks to the dependency array. After fetching, we update the username state with the received data. This pattern is handy for any data fetching that depends on changing props or state, ensuring the UI is always up to date with the latest data while handling asynchronous operations neatly. A common pitfall in stateful components is excessive re-renders. This userList component fetches a list of users and displays them. While it looks simple, imagine the component re-rendering every time the parent component updates. This could lead to unnecessary API calls and performance issues. To avoid this, we use an empty dependency array in useEffect, ensuring the data is fetched only once when the component mounts. It's crucial to manage side effects and dependencies carefully to prevent performance bottlenecks in your React applications. Misusing state and effects can lead to unexpected bugs. Here we have a timer component that counts up every second. The useEffect hook sets up an interval to update the second state. Notice the return statement within useEffect. It's a cleanup function. This is crucial for avoiding memory leaks in your components. It clears the interval when the component unmounts. Without this cleanup, the interval would continue running even after the component is no longer in use, leading to potential performance issues and bugs. In larger applications, state management becomes more complex. Here, we're using the context API to pass data through the component tree without having to pass props down manually at every level. We create a user context to store our user's state. The app component provides this context with a user object and a setUser function. Then, in the user profile component, we access the user data using useContext. This pattern is a powerful way to share state across many components, making our code cleaner and more maintainable. Optimizing performance is key in stateful components. Here we have a search component that uses a callback to handle the search action. The useCallback hook ensures that the handle search function is not recreated on every render unless the search term or onSearch props change. This is particularly useful when passing callbacks to optimized child components that rely on reference equality to prevent unnecessary renders. By using useCallback, we can prevent unnecessary re-renders and keep our component performance smooth, especially in cases with complex state logic or in large applications. Deciding between stateful and stateless components depends on your needs. In this example, we have a component chooser that renders either a stateful component or a stateless component based on a prop. The stateful component manages its own state, demonstrated by a counter that increments with each button click. On the other hand, the stateless component is a simple functional component that always renders the same output. This illustrates how stateful components are used for dynamic content that changes over time, while stateless components are great for static, reusable pieces of your UI.